Welcome to a lesson with Dr. Powell. Let's look at the pigeonhole principle. Um, let's suppose that we have some bricks and maybe they come in um, six different colors. Okay, so there's six different colors of bricks. Okay, now let's also suppose that we have seven bricks. Are we sure that that at least two of the bricks must have the same color? Now, might seem pretty simple, yes, because if we think about this, if we put all the bricks out, there's only six colors and there's seven bricks. And if all of the bricks had different colors, then there would be seven different colors. That would be a contradiction, wouldn't work. But we can also formalize this in terms of a pigeonhole principle by using a function from a domain to a codomain. So the colors are going to represent the codomain. So picking the choice, so looking at your brick and seeing what color it is a function. Okay, and so we're going to go a function from colors from bricks. Okay, so the size of the codomain, and this is it doesn't even have to be a surjective function necessarily. But we know this codomain has six. Call this C for codomain, and the size of this codomain is six. And we know that the number of bricks, let's call that the domain. And let's look at the size of the domain. It's the size of the domain is 7. So since the size of the domain is larger than the size of the codomain, that actually tells us that our function cannot be an injective function. Remember what injective means. Injective means that if you make a fiber box diagram, then no fiber has, or no box has, more than one thing in it. So think you have 6 different possible things on the for the output in the codomain. So that's like 6 different fiber boxes. 1, 2, 3, 4, 5, 6. Okay, so this is like for color 1, color 2, color 3, color 4, color 5, color 6. And then within these boxes are the bricks. So how can we put the bricks in? We have 7 bricks. We start putting the bricks in. 1, 2, 3, 4, 5, 6. And where do we put the 7th brick? It has to go back into one of these. So this is the worst case scenario. The worst case scenario means that this can't be injective. So that's what the pigeonhole principle says. If the size of the codomain is smaller than the size of the domain, and for a finite function or a function between 2 different finite sets, then the function cannot be injective. A statement of not being injective means that there's some color that has at least where 2 are the same. And so that's a formalization. You can go out and find other examples of this pigeonhole principle and formalize it, actually create a function, domain and codomain, and then explain why this works, namely that it's not injective with a firebox diagram perhaps, and the reason why is because the codomain is smaller than the domain. Thanks for watching.